Um, my name is Ali Siblani, and I always go by Al because a lot of people have a problem sometimes saying Ali. So I'm going to go back to my basics as I come here today, and everybody can call me Ali. I'm the CEO of Envision Tech. Today what I'm going to talk to you about is, first I'm going to talk about my company a little bit, then I'm going to talk about myself, my journey, and then as an entrepreneur who has been able to succeed and take my company to a bigger level, what are the advantages, what are my thoughts, the basic skills that I had that I think allowed me to get to where I am today. So give you a little bit of history on Envision Tech, my company. Before I do that, let me just go back a little bit. And I graduated in 1990 from here. In 1993, well, you know what, let me go back. Let me start with the company. I founded Envision Tech in 2002, and basically Envision Tech was, came out of the idea that I was very familiar with all the 3D printers in the market, and I wanted something that would take advantage of what I know from these printers and then come up with something that would be better and would address all the issues that all my customers have had in the automotive industry, because as you come out of Michigan, you always work for the automotive industry, fortunate or not fortunate. But in 2002, I started Envision Tech, a company for the development and manufacturing of 3D printers. And then the company grew over the years, and we have a factory right now in Germany for making high precision printers called the Per Factory, also known as your personal factory printers. We have a facility in Ferndale, and we just acquired about 4 months ago the former design center for Ford Mercury, where they used to design the Mercury cars, and that's going to be the new factory for Envision Tech out of Michigan. We also have an R&D facility in Montreal in Canada for chemistry development, and we also have a factory in California, out of all places. One of the things I've always thought about why I did, given the tax brackets there. But so far today, the Envision Tech employs about 700 people worldwide between all these different facilities. Just to give you a little bit of, this is some of the product lines that we produce. The first three are the three-dimensional printers that are used in different markets. You have the Ultra product, which is used in the MCAD space, the mechanical CAD space. It's also used quite a bit in the educational market. A lot of the universities have them. The Per Factory product is our flagship, and we have about 4,000 systems in the market today. This product is used in so many different applications. Originally, it started out in the jewelry market, out of all places, because we produce the highest quality jewelry part. And so today, I can tell you without any doubt that Envision Tech is a global leader in the jewelry market as it relates to making three-dimensional waxes for model printing of jewelry. Another thing where the Per Factory has really kind of became a market standard is in the hearing aid industry. In the hearing aid industry, we are a global leader at Envision Tech. Pretty much, if you look at GN Resound, Beltone, Phonak, Oticon, so about, on the average, in the US alone, 600,000 custom hearing aid shells are produced every month on our machines. So the Per Factory product was our flagship. The Aureus is a little baby of the Per Factory. It's a smaller desktop printers, and that came out of my philosophy as you evolve to address the market needs. So you're going to see that as I talk about the way I do things, we came up with a product called the Aureus, which is a desktop printer, and that was originally designed to address the needs of three markets: a jewelry market for the individual small retailers who wanted to make custom jewelry, a it's also addressing the small hearing aid companies in third world countries or in South America like Colombia and Costa Rica, where people are not doing a lot of volume. And it also became very popular in the last 12 months, where we are getting a very strong global position in the dental market, where people are doing caps, crowns, and bridges, wax-ups for the teeth. The last product really is an amazing product that nobody has been able to get anywhere near us on it. We were the first to acquire patents on it, and that's the 3D bioplotter. And the 3D bioplotter, this project was started in 98 at Freiburg University, and I got more involved in it, and EnvisionTech acquired the rights to the patent and continued to develop it out of Europe for tissue engineering, for making scaffolds, collagen, bone regeneration, and printing of titanium. This product, we started working on it again in 98. It became a real sellable product in 2002. Between 2002 and 2010, this product was only sold in the educational research type of companies, and now it's making it to the commercial. So for the last couple of years, we see people that are in the cell printing business or the bone regeneration business that are using this product in actual medical applications. Some of the applications for this product have actually made it about 2 months ago on the front page of the Wall Street Journal, where the esophagus was actually burned out from cancer, and the part was printed on the machine. The scaffold was printed on the machine, and the skin was regenerated, and it was attached, and it was 100% success story for a real, actual building of human parts. This is kind of interesting what you're looking at, because it demonstrates a couple things. The company, this is actually our company. It's a lot of faces with a lot of attitudes, but it all come cohesively together. And the reason I put that together is because on March 29th, the first full 3D printed animation movies from Sony Pictures will come out. It took 3 years to make. 200,000 characters were printed. All were printed on our machine. And the whole movie, from start to finish, took about 3 years to develop. And I brought in a little clip at some point. I'll show you how they actually worked on the movie and made it all together. So this movie is basically the combination of a lot of things that were put together in order to develop a product which came directly and only based on our technology. And we were given that opportunity and thanks by Aardman, which did all the work, and Sony Pictures. I think they're going to be printing 30 million CDs. So if you ever buy that CD at the end of the movie, you're going to see how it was made, and you're going to get a chance to see a lot more our technology and how it works. So just, whoa.
There you go, lads. Look and learn. Yeehaw!
My name's Amanda Darby. I'm the RP supervisor. The term RP is for rapid prototyping, and our job on this film is to do all of the heads and all of the mouths needed for the feature film, which runs into thousands and thousands of mouths.
But Captain's London? The home of Queen Victoria?
We get a list through of all the mouths that have been chosen for the lines. It comes through to set up and print on these machines. In this room we've got sanding and cleaning. We go through hundreds in here a week. And then we come through to the painting process. We've got the back to mouth and teeth and the tongue to prime, and then hand paint. It takes a lot of concentration. We come across here to the spraying side. We give them generally three coats of spray to a very sort of high level finish. This is the RP library, and each set of shelves and each coloured sticker represents a character and a sequence ready for the studio floor.
Ah, here we are. Charles Darwin, at your service. So, are we done here?
So that's the movie that's coming out next week, and it's all entirely made courtesy of Envision Technology. And again, this comes from the hard work of everybody and my team at Envision Tech and all the machines that we came up with, the material development that's needed, all the skin tones that match all the different characters in the movie, etc. You'll probably hear a lot more about it, and you'll see a lot more of our stuff coming down. All right. So now let me talk a little bit about myself. I went to school here. One of the most interesting things that I walked in is that I graduated in 1990, so I went to school in 1988, 89, and 90. And it's interesting to see, back Lawrence Institute of Technology versus Lawrence Technological University today. Thanks to all those who actually have worked very hard to make it a success story. But in all honesty, I never got a chance to spend a lot of time at the university. And the reason I never got a chance to spend a lot of time at the university because I was working all the time. I didn't have financial aid, so I actually had to pay. And I remember I was a foreign student, and I think it was $2,000 every 10 weeks. And so you had to work 70 hours a week, but I still wanted to go full-time and get 18 credit hours every term. So that's how I managed to do this. And that kind of built my character in a way and gave me that toughness that it doesn't matter what it takes, I'm going to do it. And so we got my BSEE, and I think I graduated with 3.9 or 3.95. So it was a good GPA. And then I went on to work to Wayne State University, where I got my master's degree in electrical engineering, and I also got a 3.95. The one thing that I really want to say about Lawrence Tech, which is really something I carry along, is the logic and the train of thought and the analysis that I picked up. This discipline I carry with me every day since I was a kid here at 21 years old, taking classes just like some of you right now. When I graduated, I went on to work for a company called Helicis, which is a manufacturer of rapid prototyping equipment out of paper. And so they would take sheets of paper, they would cut them, and then they would glue them together. So it's like wood, you make paper, then you take the paper and you cut it back, and you get the wood, but in the shape that you want. And that was Helicis' company. I worked for Helicis for 9 months, and I installed every single machine at every single manufacturer here in the automotive industry. I installed, I think, about 15 or 20 in 9 months. And I remember this very clearly today, that I was at Ford Motor Company down at the design center, and the bearing was broken on one of the machines. And I picked up the phone, and Helicis was a small company at the time. It was like 5 or 6 people. And I said to the owner of the company, I said, the bearing is broken, and we really need to replace that graphite bearing on the heater. And he said, just go ahead and glue it. And, in all honesty, I'm proud of that engineer and everything that I learned, and I paid so hard for it. I'm not going to glue a bearing. And I said to him, I'm not going to glue a bearing. And he said, well, if you don't do that, you know what's going to happen. And I hung up the phone, and there behind me was the head of design at Ford Motor Company. And he came up to me, and I was a kid, and he tapped me on the back, and he said, listen, kid, in this town, you can always get a job. But if you lose your credibility once, you'll never get a job. So he said, go home, open up a company. I'm going to set you up as a vendor, and you're going to start doing business, and you're going to service these machines. And that's how Sipco was born, out of Civic Center Drive, out of my apartment in 1993. And so that's the real story, how it all got started. So it got started, and then from 93 to 98 to 2002, I was working, delivering materials, supplies, services for all the RP manufacturers. And I was thinking, how do I come up with a machine that works best, that is better than all of them? So in 2002, the idea came through, and it was completed, and that was that's when EnvisionTech was born in 2002. EnvisionTech basically, like we said, is an equipment manufacturer. We made a lot of equipment, and so far today, I think I have about 90 patents between the US and globally in patent applications that are in the field of rapid prototyping. I've done quite a bit of publications, mostly in the world of photonics, bone regeneration, and rapid prototyping. A lot of it was co-sponsored with some of the professors at universities that we were engaged in, and we hope to see more of that as we engage more with Lawrence. Now, I think probably what I want to tell you more than anything else is that I never came here today to talk to you about the standard stuff that what is an entrepreneur, the standard things that you read. I'm going to tell you my story, and I'm going to tell you what I think, and some of it might be a little bit off the wall, but I think it'll give you a different insight about somebody who was able to succeed to a certain extent given the size of the company that was started by me and continue to grow the company at an exponential rate. Our average growth is about 35% last year, and I think we expect it to be the same for the next 3 to 4 years. Here's some of the things that I wanted to talk about, especially as it relates to entrepreneurs. Everybody knows that in order to be an entrepreneur, you have to be a leader. Okay, great, we know that. I don't think in order to be an entrepreneur you have to be a leader. I think you have to be an evolving leader. You have to be a different kind of leader. So when you start your company out of your apartment in Southfield, you're a one-man show, and you have a phone, and you talk to the people that like you, and develop relationships, and you start selling. And then you make a product, because we all know that a company is started either from a product becomes a company, or a company makes a product. Every entrepreneur has a product, and he makes a company. So you have a product, you make a company, and then you start. And then the company starts growing and growing and growing. And one of the things that I've noticed from people that I worked for and people that have failed is that as a leader, they did not evolve. I always said that somebody who's running a company at $3 million have to have a different set of mind than that is running a $10 million company, and that's running a $20 million company, and that's running a $50 million company. So when I was actually, that was the biggest challenge for me as an entrepreneur, is how to go from having a company which is a $3 million company to a company which is having $100 million in sales, and still maintain that balance in my head. My skill set has to change, so I have to evolve as a leader. And that was very important for me. The company that I used to work for, where I got fired from my job, it went out of business in '96. And I thought that the main reason for that was that the leader for that company, even though he was creative and innovative, but he did not evolve as a leader. So he went on to become the person that at $15 million, he still was concerned about who was purchasing the toilet paper in the company. And that is really one of the things that I always wanted to make sure I don't fall into. So I kind of tried to upgrade myself and evolve. And as the world evolved in the last 5 to 7 years, when we talk today about marketing, even if you're a $100 million company 5 years ago, we were talking about marketing, a marketing specialist, a marketing coordinator, a marketing campaign manager. Today we talk about a social media marketing manager. Well, that's completely different. So now, if I don't evolve and I don't embrace LinkedIn and Facebook and Twitter, I'm going to be in trouble. if I don't embrace all these changing dynamics of the market, I'm going to be in trouble. So I think to me, the biggest challenge to me as an entrepreneur to go from 5 million to 50 million to 100 million is to actually be able to embrace a new set of dynamics and leadership values and continue to be the same person I am with the solid beliefs that I'm still not going to glue a bearing. That's the basic that I always go back to. So there are basics that never change, and there are things that are going to evolve in a leader. The second point that I always thought was quite interesting, and it did really work for me, is to be interested in everything around you. I think that if you wanted to be a good entrepreneur, you have to be interested in everything that goes on around you. It doesn't matter if it's important and makes you look really deep and thoughtful. It could be something ridiculous, but if you can talk to a child about a game, and if you can talk to somebody in politics, and you can talk about soccer or football, if you're interested in things about you, then you become an interesting person, and then people are more interested in you. And if people are more interested in you, they want to be associated with you. And they're associated with you, they're excited to be around you. And if they're excited to be around you, there's a comfort level that you develop with them. And if you develop that comfort level, then there's trust. And if there's trust, then they're willing to work with you and do things for you and be more forgiving with you. And I think an entrepreneur has to do a lot of that, develop that interest level in you. And I think that's one of the things that I found to work quite a bit for me. There's a lot of examples I can give you, but I think my first relationship with HP, we're doing a project with HP in three-dimensional printers. And the first relationship with HP started with the head of a division there that was interested in soccer. And that got and then, because of the interest in soccer and the common interest, found me interesting, and I found what they had to say interesting. Then we started talking about the things that matters on the business side, and that led to more and more things. So again, being interested is very important. The third thing that I really like is an entrepreneur will never be an entrepreneur if you're not selling. But you can, if you try to sell and you're a salesman, you're going to fail as an entrepreneur. I'm always an engineer, so the first thing I need to deliver a message when I'm selling is that I'm an engineer, first and foremost, and I deliver based on the merits of the product. I always try, when I sell, I try to offer the person standing in front of me not a machine, but a solution to a need that he wants. And I think if the entrepreneur, if you offer a solution to the person of what he wants, then you're going to be very successful in delivering and selling without being a salesman. The fourth point that I also like to talk about is dynamic strategy equals dynamic products. And in the beginning, I was talking to you about the large per factory system, which is a product that we make 40, 50 machines every month that sells for $100,000. And so we went to all the Tiffany's of the world, the Katakoris, all these big jewelry companies, all these big hearing aid companies, all these big toy companies. But now we wanted to address Ahi Jewelers down the street. Well, Ahi Jewelers doesn't do 50 designs a day. They only do 2 or 3. So we had to look to address their needs. So I wanted to make sure that we come up products. We have a strategy in the company that would allow for products that would continue to allow us to compete in markets. And that is kind of, from my skills as an entrepreneur, that was a touchy subject, because if you go to your team and you develop a story and you tell your whole team the story about what you want to tell everybody, and they take it down your organization, when you try to be dynamic and retweak your strategy based on market conditions, sometimes you'll get a lot of fighting inside. So it's very tricky, and you have to have the skills as an entrepreneur to retweak the strategy and resell it without being afraid, because I've seen that in some of my lower management trying to resell my retweaked strategy and struggling with it, and that would cause issues. Today in the three-dimensional printer market, there's a huge debate in us manufacturers. Do we make a $1,500 3D printer, or do we keep it at $10,000? Is there a market for a consumer 3D printer, or is there not one? So, you know, there's only about 5 or 6 of us like me in the world that owns or run 3D printing companies, and we're all disagreeing. Some people think we have it. Some people think we have content. You know, if I sell a 3D printer for $1,500 at Best Buy, and somebody walks in, well, you need to develop the content to print something. You need Microsoft Word, Microsoft Office. You need something, and that does not exist today. So I was completely against the idea. I still don't think that it's yet ripe enough in terms of content availability for the regular Joe to go and buy a printer for $1,500. But I was also, if you look at EnvisionTech, our cheapest product is a $40,000 product. And now I'm seeing that, okay, we need to tweak and go down to a lower level and deliver more value for the small design firm that has a wide plotter printer and they want to have a 3D printer. So now, all the last 3 years, I've been telling them we're not going to drop our prices. Now, I'm changing my strategy, and this is where I have to take all those people that have been preaching this high price and now tell them that I want to come up with a $10,000 printer or a $20,000 printer. And that's tricky because a lot of the entrepreneurs that are friends of mine avoid that. It's like their ego is too big to actually go back and say, you know what? I think things are changing. And so that's a very important, having a dynamic strategy and dynamic products to address the customer needs. One of in the last 20 years, I think the one thing that's been the most important for me and the most successful thing as an entrepreneur is learning how successful people that I've watched migrate technology from one industry to the other. The largest dental lab in the US is called Glidewell Dental Labs. It's the owner of the lab. His name is Jim Glidewell. He's in Long Beach, California. He employs 2,000 people. He is by far the largest lab. In 2003, I was exhibiting at a show called Euromold. It's a molding and machine shop show in Frankfurt. And he came up to me like any other customer, and he was talking to me. And then I never knew how big he was. And he was one of those people that when he says something, the whole industry follows. So I asked him, why is he in the dental business and he's doing this? And he told me that this is what he does as an entrepreneur, regardless of how big he gets. He goes out there and he tries to bring what's in other industries and migrate it to the dental market because he wants to stay ahead of everybody else. So that's when I started learning about that idea of always, as an entrepreneur, you have to keep your eyes open and your mind open at any different industry and find out, is there one possibility to migrate my product and integrate that product into that industry? And so, yeah, we did. And now, if you Google EnvisionTech, you'll see EnvisionTech, Cadent, and Sirona are the 3 largest companies in the CAD/CAM market in the US. So that put us on that headline in terms of market penetration in the dental market. And that all started because of that little idea that I learned. Before that, I was in the jewelry market. So we started out in the jewelry market, and then we went to the hearing aid market, again by mistake. And then we became a market leader in the jewelry market. Then we became a market leader in the hearing aid market. And now we're capturing quite a bit at a very fast pace the dental market. And that's simply from learning about this migration between one industry and another. So there's a lot of power in looking as an entrepreneur at other industries and trying to take what you learn and what you know and help provide them a solution. But there's something else, which is the bad side of this, that I learned. if you try to migrate, you better understand that market very clearly and what the expectations of that market are. Because sometimes the expectations in the hearing aid market is plus or minus 100 microns on the hearing aid. But the expectations of a crown is plus or minus 20 microns. So here I am, I see some similarity, and I jump and I start putting all my machines in the dental market. Ouch. People are calling me and saying the margin on the teeth is not closed. Microbes are getting in. I have to worry about it. So, of course, as a company, we learned that very fast because we do beta testing and we put the product to testing. But I also learned that before you migrate from one market to the other, understand the basic requirements of that market. And do not try to offer a machine. Try to offer a solution. Because in the dental market, you scan the impression or you scan the model, you design the coping on the crown, then you print it, and then you cast it. If you try to do this and you bring in the machine to print, and if anything goes wrong, you are the one responsible, the printer, because that's the one you're holding the end product in your hand, and that's where it's coming from. So in conclusion, on the migrating and implementing your product, you have to understand the market very clearly, the requirements of the market, and make sure that you deliver a solution and not a machine that could be part of the solution. You have to understand what the requirements are. Just on the dental market, because I think that would be interesting for you to know. You know, and now we go to the dentist and everybody takes an impression and they send the impression to the lab and then they pour the gypsum, they make the teeth, they do, then it comes back. So in the next couple of years, and that's what we're working on, what is called the intraoral scanners, where you don't have to put that goo in your mouth anymore and bite on it and then send it. So now we're going to do this intraoral scanner, and then the data goes straight to the lab, and the lab will do it. Now, when the data goes to the lab, we design the model, and then we print the model. And we are a printer. I'm in the jewelry market. I'm in the hearing aid market. I don't know anything about caps and crowns and bridges 4 years ago. As a matter of fact, I don't know anything about hearing aid or jewelry. I used to know what I learned because I lived down the street, and my dad or my uncle went to Ford Motor Company. I know about the transmission, and I know about, the engine block, and these are the things that we're born in Michigan to learn. So the point that I wanted to make here is that as you go into these markets, you need to understand exactly what you are getting into, because if you don't, the market will not forgive you. Any migration that fails means you're out of that market. The last thing that I learned as an entrepreneur, and I think that's a common one, but I think it relates to the fact that I worked 72 hours a week, and I did 18 credit hours at Lawrence Tech, and I went for about 3.5 years, and I graduated with a good GPA, is that it gave me that, it doesn't matter how many times you're going to knock me down, I'm still going to get up, and I'm going to do whatever it takes to be successful. So along the way, every morning I wake up and I'm trying to think, who's filing a bogus lawsuit against us? Because the bigger you get, the more bogus lawsuits you get against you. Another thing that I wake up every morning and I say, okay, I look on my email first. Is there somebody in China trying to knock off our machine? Or in Korea trying to knock off our machine? Or a do-it-yourself project who's trying to make a $2,000 printer with one that looks like the one that we're selling for $45,000. This is what I wake up doing every day. But we continue to innovate, and so as an entrepreneur, I don't stop waking up every morning and worrying about these things, but I also try very hard to continue to innovate and move forward to deliver solutions that will make the world a better place. Case in point, as a closing remark, we were the first 3D printing company to get FDA approval for making teeth that goes in the mouth. So you can actually print in 1.5 hours a tooth that goes in the mouth. You know that a crown would cost you, depending on where are you in the country, somewhere between $350 if it's a nice doctor, and $1,200 if you're in Beverly Hills on Cannon Drive. The cost to print that tooth to the lab is $2.39. You know what that means? You know when you look at all these poor countries and you see all these missing teeth, now for 20 bucks, you can get about 7 or 8 teeth. And that's good enough for you to chew at least. And so that's one of the things that I like to say in the end, because at the end of the day, you know, we're humans, we're trying to contribute something to make this world a better place. And I hope by doing this, I give you a little bit of insight about the company, myself, and my beliefs as an entrepreneur. Thank you very much. I'll open it up for questions right now. Yes?
Yeah, very impressive. And being an entrepreneur, they say a lot of times your family background or your environment as you're growing up as a child is very important. And I missed the first part of your message here, so I apologize if I missed it. But I was curious, in your family, with your parents, how did that either prepare you for like what you've been doing entrepreneurially?
Well, there's a lot of truth to that, because one of the things that's always interesting, I keep reminding my dad, is when I graduated and I got my bachelor's degree, he said to me, I said, are you going to come to the graduation ceremony? And he said, what? I said, graduation ceremony. He says, I'm not going to a bachelor's degree graduation ceremony. When you get your PhD, let me, and I will go. So that's a true statement. On the other hand, the mother, you know, it's a softer side. She said, oh, I missed it, but I'll go for your master's degree. So the expectations are very high that, at least in my family, that a bachelor's degree is equivalent to a high school degree as far the minimum you're expected to have is a bachelor's degree. So to put your parents through the effort of going to a graduation, you got to go a little bit beyond a bachelor's degree.
What level of education did your parents have?
My mom has a bachelor's degree in journalism, and my dad has a master's degree in engineering. But there's something important here that I want to tell you, which I think, because this had really no impact on me, because the truth is, when I graduated from high school in Beirut, my parents put me in the best schools. They put me in International College, which is a New York-based school, and you know we were very comfortable financially at the time. So as soon as I came here, the value of the Lebanese lira went from $1 equals to $1 was 9 liras to $1 equal 35 liras. So after I got my first tuition for the first semester, I called my dad. He said, "Guess what? The exchange rate went from 9 to 32. Have a nice day." And that from 1985 till today, my dad paid $900 for my education. Yes?
Can I also ask you, too, that could what you have done in the 90s be duplicated anywhere else in the world, or what about America made it unique in an environment that enabled you to be able to accomplish this?
I think that without a doubt, this is the land of opportunity. And there's a very good reason for that. And I'm not going to get this emotional, give you the story about America the Great, because it is great and we all know it. But there's a very good reason for that. And that reason I became to learn over the years when I fly in all my VP of sales managers from the UK, from Germany, from China. And every once in a while, you know, we do about 150 shows a year because we're in so many different markets. And so I would bring them in just for them to get a taste of how the US business is being done. Even though they're Europeans, and we think it's not that different, the English are not different, you know, they're our cousins. And then, and when we go to China, they do I'll tell you, in my opinion, why the opportunity is there. And that came out of the mouth of the VP of sales for Europe for me. He says, I've done sales in APAC, Asia Pacific and China. I've done sales in EMEA, Europe and the Middle East and Asia. And he said, I've never seen people that make a decision to buy something and then act on it faster than anybody else in the world. And that is my experience. In this country, when you get somebody, the American capitalistic way of mind works in a way that has nothing to do with just I want to make money, but that I found something, it works, I'm not going to sit and study and study and study and waste time while everybody's doing something else. I'm just going to go ahead and make the decision and buy it. Mind you, the big opportunity here is that they can go to the bank and get approval, or they used to, because it's getting better right now. But I think the speed and the decision making, so that you can catch that train and be the first one on it, as part of the American culture, is the most important aspect of capitalism that I see, that allows for this opportunity to foster here more than anybody else, anywhere else in the world.
But don't you think that's your integrity and quality of the product too in the United States? If it's good, they're going to get it. If it's not, then they'll leave it alone. And when it's, especially with Facebook and Twitter and now, if it's quality, it's gone. It's just...
Well, yeah, but let me ask you the same question. It takes us, we were doing a study on labs that are buying the per-factory printer for making wax-up crowns, bridges, pressed over, you heard the Emax or all these different pieces that go, or units that go in the mouth, restorations, that's the word I'm after. Why does it take, the product is a solid product, it has the reputation. If you do some research, you'll find out it's a very good product. Why does it take the guy today at Midwest Lab, he already made the purchase, about 30 minutes to make the decision? He said, I made the research, I spent 1 week doing the research, I talked to a lot of people. He got on the phone, he talked to our sales guys, he made the sale. While it takes 4 months for the guy in Germany to buy the same machine. Why?
How they're raised, maybe?
That is a possibility. That's why they call it gray weather in Europe all the time.
Well, yeah. I was just saying,
Sorry, go.
I was just saying, I lived there for 11 years, and it is a difference in there. But I think the school system, the education system, really, and how they're brought up is different in different countries, because I lived in Asia for 5 years too. So I think we're more freer to, well, I guess, think and do quicker than that because of the upbringing.
And that's what's great about this country. That's really the point, the ability to actually have the freedom to make a decision and act on it and not wait for 3 months and evaluate and reevaluate and reevaluate while the world has gone by. I mean, I'll give you a very simple example about this specific application. Olsen Dental is a company in Macomb. And 4 years ago, it's a big lab. They have 150 people. 4 years ago, I walked to the lab, and I looked at the walls. And if you've ever been to a dental lab, they make these boxes for all the cases that's in them. And I walked to the lab, and the wall was empty. And I talked to Ron, the owner. He retired now. And I said, Ron, why are you not busy? You used to be one of the biggest labs in Michigan. And he said, well, if I have to get a dental technician to do one anatomical crown, it takes him 20 minutes. 20 minutes at about $30 an hour with his benefits. That's about $10 is my cost to make a crown, a wax crown. In China, it will cost about 20 cents in labor cost. So what we did, at least as Envision Tech, one of my thoughts has always been, is that if you eliminate the labor, the hand labor factor, then you create this flat ground economy. And so how do you do that? You come up with a machine that it takes you 2 minutes as a technician to design the crown, and I can print 95 of them in 2.5 hours. Guess what? That 20-minute factor is no longer. So I put the machine in, and then 1 year later, I see the whole lab pumping. It's full with people. And I see that wall, and I walk in, I look at Ron, I say, look at all these boxes, Ron. He says, yeah, because now we don't have to worry about labor. Labor is irrelevant in the overall cost. So every time we take this, what I call labor, hand manual labor, out of the formula, business will always stay here. And that's a fact. And I've seen it many times over.
When you were talking about Germany, she said something that I think we all missed. We were wondering what word she replied to your early discussion about why Germany was taking 4 months to make a decision.
She said it was the school system or the way of thinking. Is that what you're talking about?
I don't know.
Well, they get weeded out kind of in the 4th grade. I have a niece there, and she got to go to high school. But other people, like we have a set of twins that are there. One went because she played too much, and the other one was really studious. And so one got to go to high school, and the other one didn't. And they had to pick her. They put her in something like nursing.
They're forced to pick their
They're forced
earlier.
in the 4th grade, right?
Well, I'll tell you, there's no one is closer to Germany than I do, because I have about 300 people that are sitting in one building. About 250 of them don't speak any English, and I speak English to only 50 of them. And I have all the way from PhDs and doctors, medical doctors that work for me. And what I can say about that part of it, the education part of it, is that it is more disciplined, more structured, and at a slower pace. I'll give you a very simple example. If my chief technical officer of the company says that there's a software issue to be worked on, and if I ask my development team in California how long it would take to do it, these are University of California, Irvine PhD computer science graduates. And then I ask PhD from my Gladbeck facility, there's a 2-to-1 factor at a minimum for the same exact task. So that's one of the struggles that we have to deal with, and find out how we can take the two cultures and work with them, and so make him work faster. But that has nothing to do with as a businessman, if you have a product and you have an eye for it, I don't care what your education is, what the culture is, if you really see it and you're an entrepreneur, you should jump on it and you should do it after you do some research. You don't have to wait 4 months and 6 months. Yes?
When you talked about your first thoughts in the morning, in the event that someone in another country is infringing upon one of your ideas or building something that's similar to yours, what steps could you take? Like if someone in China was doing the same thing you're doing?
Well, this is a very interesting story, because I just spent probably 1.5 hours today talking to our, we're in an intellectual property driven business, and we sue and we get sued all the time. That's part of the electrical bill that we pay on that, on being in that business. So we have 2 products right now that are getting knocked off. One of them is out of Germany. What we do when we develop our IP, we try to write the IP and we get the patents in countries where we think that 75 to 80% of the business will come from. So if I cover Germany, and if I cover the US, and if I cover Italy, France, the UK, and if I cover Japan, then I've covered 75% of the product. Now lately, we started to try, and we have been successful in getting some Chinese patents. The problem with Chinese patents is, and as I've learned, is that when you have patents in countries that don't respect intellectual property, they will only start respecting it when they start having their own. Once they start worrying about their own intellectual property, they're going to start respecting yours. But I do want you to know that getting a patent, so far from our experience in China, even though I believe maybe in 5 to 7 years it will have value, because then they'll have another 7 or 8 years on them, but it's really tough. From a cost standpoint, from a communication standpoint, and even dealing with people that are not really very versed in the patent and how it's written and how the structure is all about. It's just like they're trying to make it up as they go. And that's the experience that I have so far personally as a company with those patents. I mean, I've got patents on my walls written in Chinese. How good they are, I have no idea. Can I prosecute them? No. But the good news is that if they ever come to Germany to sell a machine, I can shut them out. If they try to come to the US to sell a machine, I can shut them out. If they try to go to Japan to sell a machine, I can shut them out. Well, if I have 75% of the market, no company can stand on its feet if 75% of the world market is close to it, right? So that's really the strategy that we follow.
In the area of regenerative medicine, there's a lot of, I guess you can say, hype and promise, potential for 3D printing. What do you see the market going in the next 3 to 5 or maybe even 10 years? Do you foresee us truly being able to print organs and tissues and vascularized tissue or joints that can actually be used in the human being?
That's an interesting question, because I've been spending money for the last 10 years at Envision Tech on this promise. So we've invested quite a bit of money in the 3D bioplotter. What I can tell you for sure is, from my perspective and my knowledge, that we should start seeing in the next 24 to 36 months more real life biopart applications that are coming out from the cells, the scaffolds. I think bone regeneration right now, even though I have a patent on it that was issued with John Fisher from University of Maryland and Dr. David Dean from Case Western, we've been very successful. We made a lot of progress on it, but I think we're still 2 to 3 years away in terms of bone regeneration. And the fact that when you evaluate the cost of regenerating a bone versus the cost of a metal right now for replacement, it doesn't make sense. But when you look at other areas, a skin, a scaffold, tissue, cell printing, I think you're going to see a lot more growth in that area. So my guess is we developed the technology. We have the system right now that can deliver the requirements for making these things. I think the next 2 to 3 years, you're going to see the material development, not the process. So as the materials develop, you're going to see more parts coming out. And that's what we see as we have sold a lot of these machines. I just came back from the biomaterials show about a month ago in Europe, and there was a company that bought one machine from ours, and they have 70 employees right now. It was a 3-company employee. And so I know that you don't hire 70 people if you're not starting to do something that somebody's paying you to do it. So I do see in the next 2 to 3 years more applications in the bioparts, to answer your question.
Earlier in your presentation, you made reference to titanium. Is that spraying a powder that's later sintered?
Yes. In our machine, that's the case. There are 2 types of machines that are doing it right now. One is laser sintering, and there's a company called EOS out of Germany that does that. There's a company out of Schneider Prototype that does that out of Germany. I think there's a company out of France that does that. And they're doing abutments, and they're doing some knees parts by sintering titanium powder. what we're talking about is jetting a paste-like material, which is probably 90% titanium powder, 10% binder, then sintering that material to get a fully dense titanium part.
What kind of hoops does the FDA put you through when you're trying to get something approved medically?
I think from an FDA standpoint, when it comes to rapid prototyping, they have absolutely no clue. And the reason they have no clue is because nobody has done it before. So they're trying to figure it out on their own. And this is going on YouTube, so I can't talk too much about the FDA. I still have a lot of applications pending. On a serious note, it's the rapid prototyping integration into the medical field is a new thing for the FDA. The maximum the FDA has ventured to is a CNC cutting of a porcelain, or like the Surac or the InLab or these existing ones, but nobody has really ventured beyond that. So for additive printing, as we call it, because that's subtractive printing with the CNC, you start with a block and you subtract away. In our case, you start with liquid and you form it to shape, and that's the additive printing process. In our case, there's not a lot of know-how. So when I applied for the material, they said you have to get the material and the machine approved. And then they said, no, you have to get the material approved. We don't care about the machine. So instead of taking a 3-month average time, it took 1 year. That's because they were trying to figure out what to do, and rightfully so, because there's not a lot of information and they're trying to protect the public. But all in all, it's not an easy application. And I think the best advice to anybody, I would say, is hire a consultant, an FDA consultant, that would steer you through all these things. Any other questions, or we're good?
What universities are you working with for R&D?
In which area?
For development of your rapid prototyping, I guess, machines, or to explore potential various or unexplored applications. Are you doing any of that, working or partnering with, from an academic perspective?
Yes.
To translate research and discovery research?
We have, what we've done in the past is with the University of California. We've done quite a bit of projects where we assign a task that would require some research that would allow a postdoc, and then we would sponsor that. The last one that we did was exposure strategy. Our technology employs a DLP projector in order to project the image onto the photopolymer and form it into shape. So unlike laser printing, where you're using a laser or you're jetting, we actually use a DLP projector and project the image. As a result of that, there's the grayscaling for the inner and outer contours, because we don't build in layers, we build in volumetric pixels. For that reason, we wanted to explore the approach of having an exposure strategy that promotes the lowest shrinkage of the material. So that's, for example, one project that we passed on the University of California, and it was worked on by a postdoc. We have projects with the university. We have quite a bit of them. Case Western University, we're working with them on the Perfactory for the bone regeneration, a scaffold. We got quite a bit of that. Freiburg University in Europe, Loughborough University. We probably have over 30 or 40 universities that we're actively involved in, whether you're talking about the University of in Grand Rapids. There's a university that does a lot of the metal and design for jewelry, or whether you're doing bone regeneration with Case Western, or whether you're doing something with the Mayo Clinic. So there's quite a bit of activity, and I think now that I've learned more about the Legend program, I think we might be able to do more on that side.
One quick question here. I teach in biomedical engineering program here at Lawrence Tech, and your bioprint portal certainly sounds very interesting. Just wondering, so your office in Ferndale, do they have a bioplotter there, so we can maybe bring this over?
The office in Ferndale does not have a bioplotter, and there's a reason for that. With the bioplotter, you need to have the complete clean room, and you have to have all the sterilization in order to do that. And so Germany is very well set up to do that. We are doing that in the new facility down in Dearborn, which we're moving in about 8 weeks. We will have a bioplotter there. And then because you need all that support structure that goes with it. As you know, if you want to do it right, you have to have a very clean room environment and sterilization all the way around. So no, not in Ferndale, but it will be in about 8 weeks in Dearborn.
Just follow also on your, you mentioned earlier, for the bioplotter, the next step is more on the materials aspect of research and sort of investigation. I just did search on your website. You showed already you could print pretty much all kinds of biodegradable polymers.
Yes.
So can you explain what you mean by materials aspect of investigation?
You know, the best part about an entrepreneur is to say that this is above my pay grade when I don't know it, and that's truly something that I have the head of that department is Dr. Carlos Carvalho. I'll be more than happy to put him in touch with you. I can talk a lot about the materials, but that is an area that I would never want to venture to because I don't know much about it.
In a leading edge company where you're really out pioneering new things, you know, you do have to have that exercism of caution, you know, to protect your intellectual property. But at the same time, there's always the benefits of cooperation. Do you find yourself, you talk about partnering with universities, but do you partner with the industry associations or in some ways partner with your competitors in some projects or as an industry sector?
We don't partner with, there's only 5 or 6 of us in the whole world, right, as far as 3D printers. And it's a very competitive cutthroat between us, and there's a lot of know-how that we try to protect and guard. As far as going outside our immediate competitors, as far as the industry is concerned, we're very much involved with a lot of industries in the jewelry market, in the heating aid market, in the MCAD market. We have a relationship with AutoCAD, we have a relationship with SolidWorks, we have a relationship with a lot of these groups in the industry. We do benefit from it because I think also one of the things for you to market your product is to show that you can integrate your product into other industries, which was part of my migration strategy as an entrepreneur to put my product out more and make it more sellable.
So partnerships is a key way, but it's not industry partnerships, it's cross customer
a non-competing partnership. And when it comes to the universities, we're very, this is one issue because I think it relates to the intellectual property. We have pretty set, defined parameters that we work with. In other words, if we co-develop a product or something, I worked on a project with a university, we have to, we define the parameters in such a way that if we are going to pay and we're going to sponsor it, then we want to benefit from it and we don't want our competition to benefit from it. That's pretty much the parameter that we put a limit on and we define. All right?
Okay, thank you.
Thank you. Appreciate it.